Guys, I'm Elaine. Nice to meet you guys. Thanks so much for being here. Welcome to Onboarding to Bitcoin webinar. This is she256's second webinar and our first Bitcoin focused event. So we're very glad that you guys could all make it and miss the whole, pandemic situation. I'm sure it must be a really hectic time for everybody. So I hope everybody's staying safe and healthy and, abiding to social distancing rules. So welcome. This event is hosted by she256. If you guys are new to us, welcome. We are a group. We are a 501c3 nonprofit organization that focuses on, increasing diversity and breaking down barriers in the blockchain space. And we do this because we know and we believe that blockchain technology is going to be what shapes the financial and governance systems of the future, and that it should be built by those who represent the people that it should be built for. So the global and diverse population. We do things ranging from like mentorship, meetups, conferences. This would be an example of a meetup. We teach high school students, we do design-a-thons, so many great things. So look us up if you're new, and we're so glad that you guys could be here for one of our really cool events. Before I introduce all of our amazing speakers, I want to shout out and thank Jonas from Chaincode Labs for making this event really what it is today. So thank you, Jonas, and if you'd like to introduce yourself.
Hey, I'm Jonas from Chaincode Labs. My actual full name is Adam Jonas. It's very confusing. I go by my last name. Yeah, really happy to work with Elaine to put this together in she256, and hope that you enjoy the event.
Me too.
Awesome. Thank you. And now for our amazing speakers. We have Amiti from Xapo and John from Chaincode Labs as well. Amiti, if you want to introduce yourself.
Hi, everyone. I started contributing to Bitcoin Core in January of 2019. And now I feel super privileged to be able to work on Bitcoin every day. I work at Xapo, but get to just focus on Bitcoin Core. And I'm really excited about today's talk, so I hope you all like it. Yeah.
John?
Hi folks, I'm John. I am a Bitcoin protocol engineer. I work with Jonas at Chaincode Labs in New York. I'm currently working from my apartment. I've been working on Bitcoin for about 3 or 4 years now. And just like Amiti, I feel very lucky that I get to work on something cool and fun every day. And I hope that everyone here enjoys our talks.
Awesome. We will enjoy our talks because it's super cool. And we have first Amiti going through adversarial thinking in the peer-to-peer network. And then John's going to take it, talk a little bit about Bitcoin scripting, the differences in the past and the future. Then we're going to get back together and talk about onboarding developers onto the Bitcoin ecosystem and their experiences. But before we get started with Amiti, I want to make sure that everybody's aware that we have the Q&A functionality through Zoom and the chat functionality, and this event's only going to get better if you guys ask all the questions you guys have. We want to hear them all. This event's for everybody, so really take advantage, and yeah, we're excited to hear your questions. So, okay, let's get started. Amiti, if you want to take it away and share your screen.
Cool. Okay, everyone can see my screen? Yeah, okay, great. Awesome, so I'm gonna be talking today about attacking Bitcoin Core. It's a packed talk, but I hope it's followable. So to start at the very start, Bitcoin is a money, and it's fundamentally trying to change the existing centralized system of currency that we have. And the way it does so is by having nodes that are running all around the world. And the thing that makes it possible is the consensus layer, or put in other words, that all of these different nodes are able to agree on who has how much money at any time. And this was the innovation that is the blockchain. And what this comes down to is validating blocks and transactions fundamentally. And that all different nodes are able to agree on what is valid independently. But there's another component in that the nodes have to communicate with one another. And so they're sending messages to each other all of the time. And so these are concerns of the peer-to-peer network, which is what we're going to focus on in this talk today. So a node on the peer-to-peer network has concerns that include, but are not limited to, questions like what nodes to connect to, does it have enough peers, what transactions to relay, how to manage limited resources, including bandwidth, if privacy is being leaked through the transactions it's broadcasting, if the transaction will even get mined, if it has the latest block, and identifying if the peers are honest or malicious. So there's a lot in this layer. Fundamentally, we could distill all of this down to a network node is gossiping 3 different pieces of information. One is blocks, which you're probably familiar with because it is a blockchain, and those have transactions in them. And then there's also transactions that are not within the blocks, and these are the unconfirmed transactions that live in the mempool. And then the third is addresses, and this is closer to IP addresses than it is Bitcoin addresses. It pretty much is the piece of information that allows nodes to communicate with one another where they are and allow the discovery of other network nodes. So I've created a framework to try to distill the design goals of the peer-to-peer network into 5 different aspects. And one thing I'd like to mention is that this is a work in progress, and this is my own attempt at putting together a bunch of different pieces of information that I've learned over time. So treat it with a healthy amount of skepticism, and also I'm very open to hearing any feedback. So anyway, the 5 design goals. We want the network to be reliable, timely, accessible, private, and upgradable. What does that mean? Reliable means that if a node submits a valid message to the network, it will eventually make it out to all other nodes on the network. We also want this to be done in a timely manner. And what timely is identified as changes for message to message or different kinds of users. For example, what is reasonable for a propagation property of blocks for miners versus users are very different. And then third, we have accessible. And that's the idea that entities are able to participate without the cost being too high. So one aspect of this is that the barrier to entry in terms of resource investment shouldn't be too high. Like right now, you can run a Bitcoin node on a Raspberry Pi. So we define this as a pretty low barrier. And another element is that an adversarial party shouldn't be able to keep an entity off of the network. So I think that these 3 are principles that are probably important for any peer-to-peer network to be successful. But in Bitcoin, we have 2 more values. First is privacy, which is important because it's money. And I don't think any of us want our bank accounts and credit card statements to be public information. And what that comes down to on the peer-to-peer is the fact that you don't want your persistent identity to be able to be linked to your on-chain transactions. And we'll dig into this a little bit more later. Another value that we have in Bitcoin is the idea of upgradability. And this stems from the idea that if a user buys into the rule sets at a particular point in time, then they should not be subject to a development cycle that they might not necessarily be participating in or agree with. So from the rule set that they've already agreed to, they should always be able to continue to transact and use the network as intended. So this is a fundamental ethos that mostly comes down to consensus, but does have implications for the peer-to-peer network. And again, we'll talk a little bit more about this later. So here they are, the 5 design goals in this framework: reliable, timely, accessible, private, and upgradable. So let's take a closer look, starting with reliability. Say you're a node and you form a transaction, and hopefully it propagates out to all of the different mempools, which is important because you don't know where the miners are. And if the miners' mempools don't see the transactions, then it wouldn't have a chance of being confirmed into a block. One thing that could threaten it is if there was a split in the network and your split didn't have any miners on it, then your transaction wouldn't be able to be confirmed. Another possible configuration would be that your split does have a miner, but it doesn't have as much hash power as the other split, which would lead to a chain fork. And that would be a really bad situation to be in. But in this situation, I think everybody loses, like Bitcoin loses, because it's really not having any of the guarantees that are necessary for it to succeed. So I think we can agree that we don't want network partitions to occur. And there's a few different ways that they can. One of them, or part of them, are unintentional. So one example of this would be in the prioritization logic of peers. You can imagine it would be reasonable to say something like, let's give a little boost to the peers that are able to serve me transactions and blocks quicker. That probably seems like it will improve my delivery guarantees and make sure that I have the main chain tip or an up-to-date mempool. But what this could cause over time is the idea that nodes start prioritizing other nodes that are geographically located closer to them, because that's how the latency would be the lowest. And then over time, you could imagine that Australia and New Zealand start becoming their own network, and Asia and Europe become their own network, and the Americas their own. So something that seems reasonable can actually down the line create a network split. And this is something we have to take into consideration around upgrading the software as well, because if nodes that upgrade prioritize other nodes that upgrade, they could be disconnecting from those older nodes. And so that's why it's a peer-to-peer concern. So another range of attacks that could occur to cause a partition in the network are intentional by a malicious adversary. And one reason to do this could be as a technique for double spending. The idea here is if you're able to split the network into 2 different parts and you're the only one who actually knows about that, then you could spend the same funds twice in different partitions. And a particular kind of partition attack is the eclipse attack, which we'll take a closer look at. The idea here is, say there's a victim and it thinks that it's connected to the network, but really all of its direct connections are to the same adversary. And then effectively, this victim has been eclipsed from the network. And so under this circumstance, what the adversary would be able to do is execute a whole range of attacks. First and foremost, they would have unlimited time to generate blocks that include double spends. So because of the beauty of how consensus works, the adversaries would still have to create valid blocks, but they wouldn't have to compete with the hash rate on the main chain because this victim would not know where the tip currently is. So they would have an unlimited amount of time to create the blocks. Another thing they could do is censor what transactions the victim gets to send to the network, because that's their only ability to communicate with the network. And hand in hand with that, the adversary would know which transactions are those of the victim, because it has no way of finding out about other transactions. It also could broadcast fake transactions that the victim wouldn't be able to evaluate in comparison to like what else is going on in the mempool, and this could have some implications for Lightning. But really, it's this ability to get creative. There are just so many different things that an adversary can do, so we don't want Eclipse attacks to occur. And so there's a range of techniques that we can use to mitigate. One is to increase the number of connections. The more connections you have as a node, the more expensive it is for an adversary to take control of all of those connections. But we come up against the idea of bandwidth, because bandwidth is a limited resource. And this is true not just at the individual level, but also at the network level. And that's because of an idea of inbound versus outbound connections. So all nodes will have outbound connections, but only some nodes will accept incoming connections. And so we have to make sure that the network as a whole is able to support all of the outbound connections needed. So the numbers we have in Bitcoin by default are that nodes will have 8 outbound connections and up to 125 total connections. So this is a useful technique to mitigate being eclipsed, but it has its own bounds. Another technique is to choose a diverse set of peers. And we do implement this, but we're working with a limited set of information. So this is usually the information available is like at the network layer, and there is logic to implement buckets and trying to choose a diversity from different buckets, which increases the cost of executing an Eclipse attack. Another technique is for a node operator to run multiple nodes on different network interfaces. This way, the adversary would have to figure out all of your nodes and eclipse all of the different ones. So again, increasing the cost of attack. So this is a good mitigation technique, but this depends on how the user decides to run the software. So this is out of the scope of things that we can design for in the P2P layer in Bitcoin Core, but it's good to keep in mind. And the final technique that I'm going to mention is to value long-lasting connections. Again, in theme with the idea of increasing the cost of attack, you can imagine if an adversary has to run a connection for a week or a month, that's much more expensive than an hour or a day. So long-lasting connections can help provide protection. But this comes up against the principle of privacy. And let's take a closer look at why. So privacy on the peer-to-peer level, fundamentally, you don't want to be able to connect your persistent identity with your on-chain transactions. And one way that this link can be made is if a spy is able to see that, hey, that node was the first to broadcast this transaction. Then with a high degree of certainty, they can imagine that that IP address is probably participating in the transaction, likely the one sending the funds. And so if you're able to identify the source node of a transaction, this is a huge privacy leak. And a piece of information that can contribute to being able to do that is knowing the topology of the network. And something I'll just quickly mention is there are a ton of techniques to increase your privacy at the application layer. And there's a bunch of great talks on that. Like there's so many, like a variety of techniques and leaks and a lot to dig into there. So I'm not going to be talking about that, but I just want to emphasize that we're focusing on the P2P in Bitcoin Core. So let's take a look at one concept of privacy for transactions. So say this red node is your node and you form a transaction and it's in your mempool. Ideally, what would happen is it would appear in everybody else's mempool at exactly the same time. But that's not really how computers work. So the way that we have it implemented is that there's a little bit of a random time delay before it gets propagated out to other mempools. And this makes it so that maybe a node a couple hops away received your transaction before your immediate neighbors, which would make it harder for a spy to identify the topology and the source. And that's helpful, but you can imagine with enough data points that a spy would still be able to eventually deduce what the layout of the network is and where these transactions are coming from. So something that you could do to make it harder for them to figure that out is to have connections that are changing, because now they have to hit a moving target. So dynamic connections help maintain transaction privacy. And this is in tension with what we were talking about earlier, that long-lasting connections can help with reliable delivery, particularly increasing protection against an eclipse attack. And so I want to take a step back and look at this intrinsic tension. And I want to help you gain some intuition around why that's there. Reliability is the idea that you want everyone to know your message. But privacy is that you don't want them to know who you told. Said in another way, reliability is the idea that you want to tell everyone your message. But privacy means that you don't want them to know that it's yours. So hopefully you can see why these ideas are seemingly at odds with one another. But let's dig into privacy a little bit more and different sorts of leaks. Each message is offering a unique set of information that is allowing an adversary to de-anonymize your connections or who your neighbors are. And if you remember, there are three main messages that I mentioned at the beginning: addresses, transactions, and blocks. So let's take a look at how each one of these can be used to identify topology of the network, starting with addresses. So we have a network graph here, and that is the victim, and we have an adversary who spins up another node at IP number 1. So they send a message to the victim declaring this other address, and the victim tells its neighbors about it. When the neighbors try to connect, the adversary knows that those are the direct connections of this victim node. So something I'd like to mention here is that this is a great oversimplification of how you would actually carry out this attack in Bitcoin Core today, but it does convey the fundamental idea of how address messages can leak information. Next up, we have transactions. So transactions, there's a lot of different techniques that can leak information. As we already looked at earlier, the timing of the propagation of transaction can be used to de-anonymize connections. Another technique is to create a double spend. So two versions of a transaction that conflict with one another, and then you target two nodes and tell them that, and then you can probe other nodes to find out which one they have, because they'll only accept the first one they saw. And this way you can identify out of those two initial ones, which node the in-between ones are closer to. And a technique to probe is to create these chains of mempool transaction. If you've ever heard of like child pays for parent, it's the idea of spending unconfirmed outputs. And you can use the query behavior of nodes in order to identify if it has the original transaction. So there's a lot here, and I don't really have time to go into all of it, but if you're interested, the TX Probe paper would be a good next place to learn more. And our third messages are blocks. But blocks are actually a lot harder to use to figure out connections of a node. And let's talk about why. First off, they're really infrequent, targeting every 10 minutes, but maybe if you're lucky, you can have them every couple of minutes. But that's nothing in comparison to how frequently addresses and transactions can be created and sent around. Additionally, there's a network called Fiber that miners use to quickly send blocks to one another. So if you're not part of that network, it could seem like blocks just suddenly show up in a lot of different nodes, and that can make it harder to track the relationships. Also, we don't have the same element of trying to keep the source of the transaction private, With blocks, you're just trying to get it out as quickly as possible. So we don't have that app level latency. And here I have a video to demonstrate that idea. This is a really cool project. The link is on the bottom right. And what this is showing here is a depiction of transactions showing up in different people's mempools. So we're now at almost 4 seconds, and you can see that the rate of transactions showing up is kind of consistent. And we can contrast that with blocks, where here within the first second or two, you see most of the transactions appearing, or sorry, most of the blocks appearing, but then there's a huge slowdown, and this tail end is probably just nodes that are not as well connected or maybe have limited bandwidth or something like that. So that demonstrates the idea is that blocks, get them out as fast as possible, but transactions, we kind of trickle them with introduced extra random delay. So the idea here is that each message gives a unique set of information that an adversary can use to identify the node topology. But blocks leak less information. So we can use that to come up with a solution that increases privacy and reliability. And that is a block relay only connection. So a full relay connection sends addresses, transactions, and blocks, but a block relay only connection, as you might imagine, only sends blocks. So the idea is that you now have a network graph. I've depicted block relay only in purple and full relay in blue. So you have both sorts of connections on the network. And so if there is a victim and their full relay connections are overtaken by an adversary, hopefully they still have a block relay only connection to be able to get the chain tip. And that would dramatically decrease the type of attack that an adversary could execute, even if the full relay connections have been taken over. And there's also important advantages for the network as a whole. So here, if a malicious entity were to know that this is the topology of the network, they could identify that by just taking down these two nodes, they've caused a split in the network. So if there were block relay only connections, maybe those would be more effectively invisible because they're harder to probe if you're not part of that connection. And that could keep the network together and whole. So I think this is really cool because I earlier was talking about how privacy and reliability could be at odds with one another, but here we have a solution that increases privacy and thus increases reliability. And this is pretty recent. This got merged in September of last year. And so development is still occurring. And based on that, an issue was opened in October by Xapo, introducing the idea of an anchor to further increase security against Eclipse attacks. And the idea here is that if you're running a node, you can persist some of those connections and then have that in a file, and then when you're starting up, try to reconnect to those same connections, thus anchors. This would help for reliability, but would be bad for privacy because of the reasons we've talked about earlier. So we can use the block relay only connections and try to reconnect to those on startup. And then we don't have the privacy leak of transaction relay that we've discussed. And this is something that's going on right now. It's open PR in Bitcoin. If you go to the GitHub and you look up 17428, you can read all about the conversation and the nuanced trade-offs that are being considered to try to implement such sort of mitigation technique. And if you are interested, the place that I would recommend for a next step would be to look at the Bitcoin Core PR review clubs on specifically that PR. I hosted a session a few weeks ago, and we'll talk more about what PR Review Club is in the onboarding section of this event. But here you can find notes about the PR, and you can find logs from the conversation we had around it. And I think from the fundamentals that we've discussed in this presentation, you're actually equipped to engage with the different sorts of trade-offs that are really important to consider. So That was a lot of information. Let's go back over it. I put forward a framework for 5 design goals in our peer-to-peer network in Bitcoin Core. We want messages to be reliable and get delivered to all nodes in a reasonable amount of time, and that nodes are able to participate and control whether or not they get onto the network. So I think that these are important for any peer-to-peer network to be successful. But in Bitcoin, we have 2 additional values. We want it to be private because it's money, and we want it to be upgradable to uphold the ethos of the Bitcoin development environment. So we talked about how privacy and reliability can often be at odds with one another. And we talked about a particular threat to reliability known as network partitions, and a specific type of network partition that is a malicious eclipse attack. We discussed how each message, addresses, transactions, and blocks offer a unique set of attack vectors for a spy to figure out the connections of a node. And then we put it all together with block relay only connections that can help privacy and reliability. We took a look at a PR that's currently open that introduces the idea of anchors, building on the block relay only idea. Cool, and that is my presentation. I'm gonna stop sharing and see you. Thanks.
Thanks, Amiti. You have a question in QA?
Okay. Okay, the question is, why would someone want financial privacy? And is that possible with Bitcoin as it is today? So, wait, I want to try clicking this answer live. I don't know what that does. Okay, sorry, I'm just going to answer it. So, I mean, why someone would want financial privacy, I think that's a highly subjective question. If you ask me, I said I don't really want the entire world to see my credit card statement. I think that would just like I'd have to think about if there's anything I'm trying to hide from anyone, and that just seems like a ton of information that I'd rather keep to myself, and would not like aggregators to have further information on me to target me, especially as we move into this digital age. But I think everyone's idea of how much privacy they want and need is very subjective. And the question of if that's possible with Bitcoin as it is today, I think that my best answer to that is kind of, because privacy isn't a Boolean. It's not like you either have it or you don't. It's much more so a gradient. So there's a lot of ways with Bitcoin today that you can utilize it to make quite private of transactions. But there's also a lot of ways that you can utilize it to make very transparent transactions. So one example of this is reusing addresses. If you do that, then it's very easy to link one transaction to another. But if you don't do that, then it's not that your transactions are impossible to be linked, but it's that it would increase the difficulty of doing so. So we have a ton of techniques that are available today, as well as being iterated on today, that would help increase privacy. And if you really wanted to, I think that you could utilize functionality, and I mean, you could form a transaction locally and then not broadcast it yourself, but rather run a different node or send it to someone on the internet to be the initial person to broadcast it. So it's a very nuanced thing. Okay, next question. Why does Bitcoin Core decide to have 2 blocks only peers out of the 10 outgoing peers it has? What metrics did we use to decide on the number? Yeah, good question. I think that if you want the best answer, and to understand all of the thought put behind this, I would recommend going to the PR itself and looking at the discussion, because this is something that is evaluated amongst many of the reviewers. At a high level, I think the idea was that there were some simulations that were run that identified that if there are two blocks only peers, that the majority of the network would actually be connected to one another via these connections. And that also, I think there's a bound of you don't want to introduce too many blocks only peers because it is going to be using bandwidth and other resources. And we could change that number over time, but there was also an element of during the initial development of this that let's start with a number that's lower and see how things go. So that's my best understanding right now, but I would follow up by looking at the PR. All right, next question. Does churn in the Bitcoin network increase chances of eclipse attacks? Yeah, so this is a little bit what I was trying to talk about. And by churn, I'm guessing you mean churn of connections. So if the connections are overly dynamic, and to use an example that's very extreme, we can talk about like if you were always connecting to new nodes every 5 minutes, then it would be really hard to identify like more honest connections from adversarial ones, and an adversary could just spin up a bunch of connections and have a good chance that they're specifically, or like that your node would connect to them. So yeah, the idea here is that if the connections are more static, the cost of an adversary having to maintain those connections for a really long amount of time is much higher than if they were always changing. Next question. How easy is it to detect some of the attacks you talked about, like the eclipse attack? So the eclipse attack, to detect it, I mean, I guess if there's kind of two parts of it, right? One is that all of your connections to the network are being controlled by the same adversarial entity. So that would mean that they could identify like what transactions are, well, so that would put them in the position to execute a whole range of attacks, but they might not necessarily be doing that yet. So they might have control of all of your connections, but then they might not be utilizing that to prevent you from getting the main chain tip or from getting mempool transactions. So based on how they're using it, it would show up or not. So for example, if you were not getting the main chain tip, one indicator of this could be that you haven't gotten a block in like 3 hours. And so something, if you were running a node and that happened, you could just hop online and be like, okay, what's the latest block? And then compare that hash to the one that your node is reporting. And so any like company, okay, maybe not any, but hopefully every company that's running Bitcoin nodes has some sort of mitigation technique in place. But also, if you're an individual running a node, then there are also a lot of pieces of information that can be used. And also, these are not like super easy to execute. We already implement a lot of techniques, and so the cost of doing so would be high. And so it's highly unlikely that an adversary would go through all the hoops to control our connections and then not use that for any reason, because then they've just spent a bunch of energy, time, money without like much utility. And then if they're using it for anything, then depending on what that is, you probably can detect it. But if they're just using it to leak your privacy and figure out which transactions you're broadcasting, then that could be something that's a lot more hidden. All right, follow up to the churn question. What metric does a node in the network use to ensure that a peer is honest or not? Is that the length of connection? So a node doesn't really have enough information to say this peer is honest and this peer is malicious. But instead, they can use some heuristics to say, this peer has been behaving honestly for a long amount of time. Or, you know, this peer is clearly delivering me bad information. Now I'm going to mark it as misbehaving and ban it. So there are a lot of different metrics to identify good peers from bad peers. But I guess one of the takeaways that I'm trying to leave you with is the idea that the length of connection can help increase the confidence that you have in that this connection is not adversarial in terms of trying to eclipse you. But that's not true for privacy, because if they've been connected to you longer, they might have more data points. So it's a very like nuanced thing, and I've done my best at trying to break it down and to the fundamentals, but there's really a lot to dig into. So if this is something you're interested in, pay attention to the onboarding section, because we'll give you a whole range of different areas you can use and tools and sites and clubs that you can participate in to learn more and dig into Bitcoin. Cool. I guess that's all of the open questions. Thanks for having me. I will pass it over to John now.
John, John, where are you?
I'm here. Sorry. Finding the right buttons to click. Thank you, Amiti. That was great. Okay, well, I'm going to talk about something slightly different in Bitcoin. But first, I'm going to figure out how to share my screen. Okay. Does everyone see an island? Yeah. Okay. All right. Can people hear me? See me?
Yep, everything's good, John. Go ahead.
Everything's good. Okay. Thanks, Jonas. All right. And also thank you, Elaine, and everyone at she256 for setting this up, and you, Jonas, for all of your logistical support. So like I said earlier, my name's John. I am a Bitcoin protocol engineer at Chaincode Labs in New York. I'm going to talk about contracts a little bit from a theoretical perspective, but I'm not a lawyer and I'm not a legal scholar. So for all of you legally minded people out there, I apologize in advance if I garble this and say some nonsense. But before I do that, I'm going to tell you a story. And the story is based on this picture. This is Odysseus and his sailors going past the island of the Sirens on his way home from the war in Troy. And the Sirens were beautiful women who sang a very alluring song to sailors who passed the island. And any sailors who heard that song would not be able to resist the temptation of the Sirens and would steer their ships towards the island, and the ship would be dashed on the shore and they would be shipwrecked and devoured by the Sirens. Odysseus knew this was going to happen, and so he had his sailors cover their ears up with wax and wool and ordered them to tie him to the mast. And then he gave them a very strange order and said, from now on until we get past the island, disobey any of my orders. If I tell you to steer towards the island, disobey me. If I tell you to untie me from the mast, bind me harder to the mast. And so they sailed past the island. Odysseus heard the song of the Sirens, but he couldn't do anything about it. And they safely got past, and eventually Odysseus got home to Ithaca. All right, enough of the story time. I'm going to talk about contracts and what we call smart contracts. I'm going to talk about this language we have in Bitcoin called script. And then more generally about contracts on a public blockchain. I'll talk a bit about the history of script in Bitcoin, so how it's changed over the last 11 years. And then I'll finish up with some possible future directions for scripts and contracts in Bitcoin. All right, so let's get started. What is a contract? Well, a contract is in some ways a meeting of the minds where two or more parties come together with intentions, with shared intentions. And it's a situation where there's a common understanding in the formation of this contract. But a contract is also binding. So I might want to borrow money to buy a house, for example. And at some point in the future, I will pay back that money. But I know that future me would prefer to not pay back that money. All things being equal, I prefer to keep the money and the house. So I bind myself into a contract where there's a penalty for future me if I don't pay back the money. Because obviously no one would lend me money if I could just run away with it. And so this is similar to Odysseus binding himself to the mast. He knows that future Odysseus will want to go and visit the island of the Sirens, but present Odysseus enters a contract with his sailors where he limits himself, and so he's bound to the mast just as we're bound to contracts. So the concept here is limiting future me's freedom, the freedom to renege on my debt or to order his sailors to steer to the island, expands present me's freedom because I can borrow money. And this concept of contracts has existed for centuries, for millennia. It is a fundamental building block of civilization and the market economy. And we naturally think of contracts as written, but oral agreements count as contracts and have been around since prehistory. So people were thinking about this for many years as the internet came online, and it would be impossible to rederive all of the wisdom contained in this tradition of contract law and norms very quickly. If we started from scratch using just kind of reason and first principles, it would take us many centuries to redevelop sophisticated ideas like contract law. So the digital revolution is coming, and it's challenging us to develop new institutions in a much shorter period of time than that. And this is a man named Xapo, and he said, new institutions and new ways to formalize the relationships that make up these institutions are now made possible by the digital revolution. I call these new contracts smart because they are far more functional than their inanimate, paper-based ancestors. A smart contract is a set of promises specified in digital form, including protocols within which the parties perform on these promises. And Xapo was writing this back in 1996. So if you think that smart contracts are new and they're introduced by Ethereum or Bitcoin or blockchains, this predates Bitcoin by over a decade, and smart contracts are possibly older than you expected. Okay, a little bit more about contracts before we get into Bitcoin. And I'm going to outline some objectives when designing a contract, which I'm going to come back to throughout the talk. One objective is observability, that the participants in a contract should be able to observe each other's performance in that contract. Another is verifiability, and that is that participants can prove to an arbitrator at some date or contract that the contract has been performed faithfully or prove that it's been breached. Another important aspect is privacy, that knowledge and control over the contents of the contract should be distributed among parties only as much as is necessary to observe and perform that contract. And then enforceability, and that probably speaks for itself, but at the same time I should add, when we design a contract, we'd like to minimize the need for enforcement or minimize the need to go to a court, for example. All right. Enough theory, enough armchair law. Let's talk about script in Bitcoin. So Bitcoin was introduced by Satoshi Nakamoto in 2008, and we know that we can script on Bitcoin. So here's a white paper. Let's have a look for script. Oh, look at that. There's no mention of the word script in the white paper, or maybe contract. Okay, no mention of contract either. Let's scroll down a bit and look at what the white paper has to say about transactions. We define an electronic coin as a chain of digital signatures. Each owner transfers a coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner. Okay, so the idea here is that ownership of coins is defined by public keys, and then transfer of coins is executed by creating a signature with a private key that matches that public key. No mention of script, no mention of contracts here. But if we look at the first version of Bitcoin 0.1 that was released by Satoshi in 2009, we do see this function eval script. And the comment here is script is a stack machine, like forth, that evaluates a predicate, returning a bool indicating valid or not. There are no loops. Now, perhaps Satoshi thought that talking about script was getting in the weeds too much for a white paper that was just an overview of Bitcoin. But I think a more likely explanation is that this scripting system, this function was bolted on at quite a late date in the development of Bitcoin. And the reason I think that is if we look at where that eval script function is called, you can see right down at the bottom here, is called within a function called verify signature, which makes me think that Satoshi's original design for Bitcoin was this chain of signatures and public keys, but then later Satoshi added on this scripting language. Why did Satoshi do that? We don't know. We can't ask him, he's not around. But there's this mailing list post from 2010 where Satoshi says, once version 0.1 was released, the core design was set in stone for the rest of its lifetime. Because of that, I wanted to design it to support every possible transaction type I could think of. The solution was script. The nodes only need to understand the transaction to the extent of evaluating whether the sender's conditions are met. The script is actually a predicate. It's just an equation that evaluates to true or false. Predicate is a long and unfamiliar word, so I called it script. So Satoshi early on wanted to add all kinds of fancy contracts like escrow transactions, bonded contracts, third-party arbitration, multi-party signatures, and so on. And as he was developing Bitcoin, the problem was each of those special cases required special support codes and data fields and Booleans to say whether the function was used or not. And it was just this explosion of special cases. So script is the answer. It lends this flexibility to use the Bitcoin and supports a tremendous variety of possible transaction types with a very limited set of primitives. And Satoshi's reasoning was that if Bitcoin catches on in a big way, that later on people could explore these different use cases because script was there for people to use. So that's where script in Bitcoin comes from and the idea of contracts. Zooming out a bit and talking about contracts in general on public blockchains and whether they're a good fit for these smart contracts that Xapo was talking about in the 90s. So how do they fit? Well, the good news is observability is good. Participants can all see all the possible paths in a contract and they can see how the other parties acted. So that's great. And verifiability is good because the contract is on a public blockchain, everyone can see it, and participants can prove to third parties that they executed the contract faithfully. And enforceability seems pretty good. The contract is executed and rules are enforced by all nodes. So you might think at first glance that a public blockchain is a pretty good place for smart contracts. I put enforceability in yellow there because it's not all good news. In Bitcoin, we have blocks and they arrive every 10 minutes. So if you want a transaction to be confirmed, you need to wait for each minutes for the first block and you might not get confirmed in that block. And even if you are, there might be a reorg and that transaction gets undone and double spent. So we never really have a solid idea of finality in Bitcoin. Finality is kind of fuzzy. So enforceability seems somewhat good, but somewhat not good. And there are worse things. Privacy is terrible. If we want to execute a contract, sometimes we want that contract to be private. That contract might include financial information. It might include trade secrets or proprietary business information. It might include medical information. It could include all kinds of data. And we don't necessarily want the whole world to see all of that. And if we execute a contract on a blockchain, the whole world sees everything, not just now, but for all time, because it's stuck in the blockchain forever. Here's another thing, expressiveness. In Bitcoin, we have this limited set of primitives in our contracting language, which when combined can achieve quite complex things. But if we ever want to add new primitives, if we want to add, for example, time locks or sequence locks, which we did in 2015 and 2016, we need a consensus change in Bitcoin. And those things are slow and difficult to do and can sometimes get political. So adding expressiveness to the contracting language is very difficult. Fungibility is a very important aspect of Bitcoin. And if everyone can see all of the details of a contract, the outputs of that contract are no longer fungible. A miner might be located in a jurisdiction where certain kinds of contracts are illegal, and they might find themselves forced or coerced or threatened to not include those transactions in a block, which would be bad for the blockchain, bad for Bitcoin. And scalability is also not very good if we put everything on a blockchain. It means every single node on the blockchain needs to execute every step of every contract. And we therefore have a trade-off. Either we exclude small, underpowered nodes from taking part in consensus, or we limit the total throughput of the system. So those are pretty bad things about trying to use a blockchain as a platform for smart contracts. This is Andrew Polstra. He's got a really great talk from 2017 called Using Chains for What They're Good For. And Andrew says, contracts executed by explicitly published code are really only using the blockchain for one thing, to get an immutable ordering of what order the transactions happen in. All that they really care about is that their transaction is not reversed and not double spent. All of the extra details of the contract execution can be done by things that are not blockchain. All right, I'm going to have one very technical slide, and it's got some symbols in it. If you're not into that, just wait for the next slide and we can continue. But this is the only slide with symbols in it. This is post theorem. I'm going to talk a bit about logic from the 1930s. So Turing-complete languages, Alan Turing defined these in the 50s and 60s, define computably enumerable predicates. So like we said earlier, a predicate is just a function that returns a Boolean true or false. And in the 1930s, Emil Post defined an arithmetic hierarchy. So there are delta zero predicates, and they have no unbound quantifier. So an unbound quantifier is one of these all x's or for each y, where there's no bound on what it could be. So for example, for all x in the natural numbers, there's an infinite range where x can fall. Delta zero predicates, all of the quantifiers are bound. So for example, here, all x less than z, there exists a y less than z such that x plus y equals z. And then sigma 1 predicates are those which contain an unbound each sign. So for each, exists sign. So there exists an x in the natural numbers such that for all y greater than z, x is less than y. So the difference there is that these unbound quantifiers have an infinite search space. The sigma 1 predicates have an infinite search space. And Turing-complete languages define these sigma 1 predicates which have infinite search space. And that is why Turing-complete languages can contain or can express non-halting programs. Post-theorem states that computably enumerable predicates, so that's Turing-complete, predicates that can be defined in a Turing-complete language are identical to sigma 1, and that validating a sigma 1 predicate can always be reduced to validating a delta 0 predicate with a witness. So if I provide you this thing called a witness, this clue or this data that tells you that narrows down the search space, we can convert that sigma 1 predicate to a delta 0 predicate. And a delta 0 predicate always terminates. All right, so that's a lot of theory. Let's try and reframe that a bit. This is Russell O'Connor summarizing that. He's saying, in sigma 1 thinking, I'm going to write a program and everyone on the blockchain is going to execute this program and everyone will do the same thing because they're running in the same environment. So that would be something like the Ethereum virtual machine where you write a program and everyone runs it. With delta 0 thinking, I'm going to run the program myself on my computer and generate some witness data. And I'm going to have everyone only validate that witness data instead of running the entire program. It's a change of attitude that can be a lot more efficient, a lot more private, and save a lot of time. So by using a Turing-complete language, you're effectively saying, here's my proposed state transition. Please, everyone, do this unbounded search. It could take forever. And that's why Ethereum has a gas limit. Whereas in Bitcoin, we don't have a Turing-complete language. We use delta 0 thinking, and those programs are always bound. So we provide more of the witness. And that's really the difference between computation, where we provide a program for everyone to run on the one hand, and verification on the other hand, where we provide a witness and we just have people verify that witness. And it's not a binary thing. We can move along that scale. So how does this tie into our contract design? Well, if we get everyone to compute everything, that's not private, it's less private. And if we just give people a witness, it's more private. And in the limit, that would be something like a zero knowledge proof where we reveal nothing about the data inputs. For our scalability, if we get everyone to compute everything, that's less scalable. It means everyone's redoing the same work. Whereas if we do it ourselves and provide a witness, that's verification, that's more scalable. Fungibility, it's less fungible if we get everyone to compute and more fungible if we just use verification. And in terms of observability and verifiability, we still get that with verification, but it's just privately observable. Only the parties in the contract can observe that the contract's being run. And saying for verifiable, only parties in the contract can reveal to third parties that the contract has been faithfully executed. And I'm going to claim that enforceability and expressiveness are available anywhere on that spectrum. One final quote, this is from Greg Maxwell. Is this mental model similar to conventional programming? No, but smart contracts aren't conventional programming, and blockchain isn't a conventional computing environment. How often does history change out from under most of your programs? These design elements make for a clean, simple system with predictable interactions. To the extent that they make some things harder, they do so mostly by expressing their latent complexity that might otherwise be ignored. Okay, so that's the theory. I'm going to now talk a little bit about how script has changed over the last 11 years, and then we'll look forward to how script and contracts in Bitcoin might change over the coming years. So here's a transaction in Bitcoin. It has some metadata at the start and the end. At the start, we have a version. At the end, we have a lock time. And then within a transaction, we have one or more TXINs. So we can see one here. I'll explain what SS is in a second. We have one green TXIN and then ... There can be many of those. SS stands for script sig. And then we have one or more outputs. We can see one here, it's red, but we can have many. And SPK is the script pub key. So that's one transaction. We'll have a second transaction, and the input from that second transaction spends the output from the first transaction. And in the first version of Bitcoin, what happened was you take the script sig from the input and the script pub key from the output being spent, and you concatenate them and then execute them. And they're all written in the same script language. And you can see that from the code that I showed you earlier. Eval script on the script sig from the input plus this code separator thing, and then plus the script pub key from the output. Well, that was bugged. A pretty big bug where anyone could spend anyone's money. So Satoshi fixed that in 2010. And the fix was just to separate. So execute the script sig first and then execute script pub key. And you might think, why is the script sig, why is that signature a script? All it's doing is providing data, and you'd be right. The script sig really just pushes data onto the stack. And we can see from this snippet of code, that first eval script is running the script sig, and the job there is just to push data onto the stack. And then the second eval script actually runs the script, the locking script, the script pub key. Then in 2012, we introduced paid script hash. This made a change, whereas previously the script pub key in the transaction output contained the entire script, contained the entire encoding of that contract. In pay to script hash, the output simply contains a hash commitment to that script. So a hash commitment to the spending conditions. And then the script sig contains the script itself that encode the spending conditions and the satisfactions to that script. So it's a two-step process to verify that. First of all, we check that the spending script that is provided by the spender matches the commitment. And then we have the spending script and we check that the input data satisfies that script. So why do we do this? Well, there's a lot of advantages to this model. One is that the outputs are a fixed size, right? They're always a 32-byte hash for pay to, well, sorry, a 20-byte hash for pay to script hash, 32-byte hash for pay to witness script hash. That allows us to have a fixed address length. It also means that the person sending the money does not need to know what the spending conditions are. So if I get you to send me money to a 3 multisig, you don't need to know that it's a 2 or 3 multisig. That's none of your business. You just send it to an address I give you. And you can't tell because the only thing in your output is a hash output. So the evaluation for this gets a little bit more complex. You'll see at the top, it's similar to what we had before. That at this point is just doing the checking that the commitment is a valid commitment for the script that is being provided by the spender. And then this if statement, the bottom half of this is doing the actual script evaluation with the data and making sure that that data satisfies the script. And then in 2016, we had segregated witness. And this is pretty similar to P2SH. We have a commitment in the output, but we move the script, the spending script and the satisfactions to this separate field called the witness, and it works almost identically to P2SH. And the reason we do that is because the witness is not part of the TXID, and that fixes a problem called transaction malleation. Okay, last section, how are things going to change in Bitcoin? Well, we hope that we'll have a soft fork in the next couple of years to introduce a new kind of signature called Schnorr signatures. And Schnorr signatures are really nice because they have this property that allow us to add up public keys and add up signatures. And so with a Schnorr signature, we can have a spending condition that's something like a 2 of 2. So 2 signers out of 2 have to sign, or a 3 of 5. And by the time they reach the blockchain, it just looks like a single public key and a single signature. So no one else knows that it's a multi-sig. That's really good for privacy because you're not revealing to the entire world what your spending conditions are. It's good for scalability because there's only one signature evaluation for all the full nodes to do. It's good for fungibility as well. That same soft fork will hopefully include a technology called MAST, or script trees. And this is a new way of encoding scripts where when you spend from that script, you only reveal the branches of that contract that you actually execute. So rather than in P2SH where you have a commitment to the entire script, and then when you spend it, you reveal the entire script, in MAST you have a commitment to a tree of conditions, and then when you spend it using one of those conditions, you only reveal that part of the tree. So again, that's more private, it's more scalable, and it's more fungible. We can combine those two things, Schnorr signatures and MAST, to have a technology called Taproot, where in the very best case, where all the parties in the contract agree, you don't reveal any of the tree at all. You just reveal a single signature, and you can just prune away that entire tree. So again, great for privacy, great for scalability and fungibility. And then adapter signatures are something else that we can do with Schnorr signatures. And this allows us to do really interesting contracts, for example, atomic swaps, where a signature, within just the mathematics of the signature, we encode complex conditionals that we would usually do in script. So again, the entire script disappears, and all that appears on the blockchain is a single public key and a single signature. So those are some of the things to look forward to. We hope we'll get those in the next year or two, Bitcoin, but it's a public network, no one controls it, so we can't say for sure. All right, that's the end of my show. Any questions? All right, just going to try and find out how to stop sharing my screen. Okay. All right, Q&A. Good. Sorry, 1 second. Okay, anonymous attendee. How have scripts evolved from 0.1 to the current version? What functionalities have been added or removed? Well, I hope I covered some of that now. P2SH was the first big change. Well, the first changes were fixing those bugs in 0.1. And once those had all been fixed through like 2010, 2011, I guess they were all fixed in 2010. P2SH was the next change in 2012. And then a couple of new opcodes are added, check lock time verify and check sequence verify, which allow you to add time locks to contracts. And then SegWit was the most recent change. Anonymous attendee, what's the difference between Bitcoin scripts, Ethereum smart contracts? I hope I've answered that question already. Gloria Wang, since there isn't a product manager for Bitcoin, who decides what features to include or not? How do we decide what types of contract designs to be included? For example, time-locked transactions. That's a very good question. A rough consensus appears in the community. Someone proposes a change and asks for feedback. We have a mailing list where people send emails and discussion ensues around proposed changes. And there have been a lot of proposed changes over the last 10 years. And eventually people come to some kind of consensus around whether it should be included. It gets coded up, it gets implemented in Bitcoin Core, the reference implementation. And then we need some way of activating it. And the way that's happened in the past has been through miner signaling that they are ready for the upgrade. People often confuse that for miner voting, and there's a whole political thing about who controls Bitcoin, miners or users. Well, the answer is users, but we use miner signaling to ensure that upgrades are done safely. That's a really big topic, so I can't really do it justice, but I hope that's maybe answers your question a little bit. All right, Andrew Yang, what kind of smart contracts can you create with a Turing complete language, but not with Bitcoin scripting language? Well, Post's theorem tells us that anything we can do in a Turing complete language, we can do in a non-Turing complete language if we provide a witness. So the answer is theoretically, there are no kinds of smart contracts that we can do with a Turing complete language that we couldn't do with a non-Turing complete language. Now, Bitcoin scripting language doesn't have all the functionality that we want, and that's not to do with whether it's Turing complete or not. Things that we would like to add are Schnorr and Taproot. And there are various other proposals to make layer 2 contracts more powerful or unlock other kinds of functionality. Andrew Yang, do you think Bitcoin will ever completely transition over to Schnorr signatures? No, I don't think so. So the upgrades that we do, the consensus changes we do in Bitcoin are all voluntary and opt-in. So SegWit was a change we had in 2016, activated in 2017, and now over half the transactions use SegWit, but there are many that don't, and we don't force people to use SegWit. So I expect if Schnorr signatures get added to the tool belt, some people will use them very soon, some people will take a bit longer, and some people will continue using ECDSA for many, many years. Anonymous attendee, what are some good resources to learn about upcoming features in Bitcoin, e.g. Taproot, Mast, etc.? Well, the best resource is the Bitcoin OpTech newsletter, which comes out every Wednesday. It's written by Dave Harding. And if you go to bitcoinops.org, you can sign up for that newsletter. It's free, and that covers all of the technical developments in Bitcoin Lightning. So you'll hear about all the upcoming features as people discuss them. Anonymous attendee, why are scripts not Turing complete in Bitcoin when compared to Ethereum? Is it because they are not really scripts but predicates? Well, the answer is they don't need to be Turing complete. And yes, they are predicates. They are a function that returns either true or false. Sarah Reynolds, does greater privacy generally correlate with greater fungibility? Yes, it does. Those two things are very tightly linked. We care about privacy because we care about fungibility. We care about privacy for many reasons, and one reason is fungibility. You can't have fungibility if you don't have privacy. If people can see who's spending which coins, inevitably some coins will be censored, and we don't have fungibility. Anonymous attendee, why are smart contracts considered more powerful, credible, trustworthy when they still rely on humans holding up the end of the bargain? I think the idea is that we remove discretion from the contracts. If we encode the contracts and the enforcement of those contracts into an arbitrator like the Bitcoin blockchain, then there's no discretion on whether those contracts are executed faithfully. They follow the code. Maybe. Anonymous attendee, are the new features that are being introduced in Bitcoin, e.g. possibly Taproot, Mast, Schnorr SIGs, also going to be incorporated into Bitcoin variants such as BCH? I do not know the answer to that, I'm afraid. I don't know much about BCH. Anonymous attendee, can you briefly summarize again post-theorem from high-level, symbol-free manner. You mentioned that anything we can do in a Turing-complete language, we can do in a non-Turing-complete language if we provide a witness. Yes, that is the summary. I am not a logician, and I didn't study computer science to a great degree. But yes, there's a hierarchy of arithmetics. Sigma 1 are the predicates that can be expressed by Turing-complete languages, and anything we can express in a Turing-complete language, we can do in a non-Turing-complete language if we provide a witness. And in that language, those predicates will always hold. So yes, you gave a good summary, thank you. Last question for now. Why are Ethereum smart contracts so much more popular than Bitcoin script if scripts are much more efficient? I think there are several reasons. I think Ethereum is a lot more attractive for developers because the tooling is better and a lot of the complexity is hidden. Now, that doesn't necessarily mean the complexity goes away. It might just be hidden and hidden from the developers, but still exist. But I think people look at Solidity and see something that is similar to what they've programmed in before. And so it seems like an easier platform to develop for. That's my guess. Oh, one more question. Luna Swart, do you think that there will ever be a way to determine whether something like the concept of reasonableness has been met using a smart contract? Luna, I'm afraid I don't know. I don't know, is the concept of reasonableness a term of law? I'm afraid I don't know the answer to that one. Okay, that's all of the questions, I think. So I will hand back to Elaine.
Okay, okay, I'm back. So we have finished our 2 talks and we're gonna go on to the all waited for onboarding developers portion of this talk. So if Amiti and John, you guys wanna come back to the screen, I'm afraid you guys can't stay hidden for too long. Yay. All right, so this is supposed to be like a more casual, free-form kind of portion to talk about like some cool resources, like your experiences getting onboarded onto the Bitcoin, just blockchain ecosystem in general, share some tips, you know. So if you guys would just like to casually take it away. Jonas, if you want to, you know, be a part of this as well.
Sure, I can jump in.
Go for it, Jonas.
Jonas, you want to kick us off?
Yeah, I guess we're doing a moderated panel now. So Amiti, maybe you can tell us a little bit about what your last year has been like. You just started working on Bitcoin Core and has seemed to have ramped up quite a bit. Tell us a little bit about that journey.
Yeah, it's been a lot of fun. So previously I was working at Coinbase on the crypto operations team, and this was more in line with application development. My background is in like working in startups in San Francisco, which is mostly application development. But I was really interested, and so I was working there, but I wasn't entirely satisfied, and I wanted to dig deeper. And I started contributing to Bitcoin Core in January of 2019, and I really made some like very small changes, but I got hooked pretty quickly. And so I was spending nights and weekends trying to learn more and watch talks on my BART ride to work and just kind of understand more and get involved in the code base. And over the summer, I had the awesome opportunity of going to the Chaincode residency, where I was able to focus fully on Bitcoin and able to be exposed to all these different people who are experts in their fields, as well as a cohort of other residents that are trying to onboard and interested in also trying to find their footing. And so it was an amazing experience. I started working on a project in Bitcoin Core to improve privacy around how transactions are broadcast. And well, I'm still working on it. But there I started the foundation and got to design it with lots of wonderful minds to poke and prod and help me along my way. And then after the summer, I got sponsored by Xapo, where I'm now an employee, and I work with AJ Towns, who's my wonderful manager and mentor, and get to spend all day learning about Bitcoin. And I've really just dug my teeth into the P2P aspect of it, and I'm trying to familiarize myself with all of the different concerns in the P2P. So overall, it's just been like so much fun. The onboarding process has been, I mean, definitely kind of terrifying. Like, it's a huge code base, and there's C++, which I come from a background of Ruby on Rails. So I was kind of like, what am I trying to do? Trying to learn C++ in my free time. But actually, it's been a really welcoming experience. It's amazing how I think there's such a core culture of thoughtful skepticism that people have been so willing and generous with their knowledge and willing to share it with me and spend time supporting me asking thoughtful questions. And it's just been incredible. I still have moments where I think like, oh my God, if a year ago I knew that I'd be here now, like, I don't think I would have believed it. And it's really cool. So I definitely recommend, if you're interested. It can seem impossible, but if you just like take small steps towards, you might surprise yourself.
And John, maybe tell us a little bit about what kind of efforts either you make yourself or you've seen being made by in the Bitcoin community to onboard people and make it a little bit more open and inviting.
Yeah, I think there's a lot of ways now to get involved in Bitcoin protocol development. There's a great blog post by Amiti about onboarding to Bitcoin Core, which I just sent a link to all of the attendees in the chat there, and that lists several things you can do. One thing that I work on that I started about a year ago is the Bitcoin Core PR Review Club, which is a weekly IRC meeting where new contributors can get together and ask questions and learn about the review process in Bitcoin Core. The culture that I try to cultivate is that anyone welcome to come and ask any questions they want to, and there's no such thing as a stupid question. We're all there to learn. So if you're interested in Bitcoin protocol development, I would recommend coming to the weekly PR Review Club on Wednesdays. Another project I'm involved in is Optech. Like I mentioned, there's a newsletter. So if you want to keep up to date on the latest discussions and changes in the Bitcoin and Lightning protocols, subscribe to that newsletter. That's at bitcoinops.org. We at Chaincode, you and I, Jonas, and Carolee, run a residency program. We did one last summer, and unfortunately, the pandemic has stopped us from doing one in June, but we hope to do one very soon. And the material from all of those residencies is available on our website at residency.chaincode.com. So lots of study notes and curricula and videos. So there's really, I'd say, quite a wealth of material out there if you're interested and want to learn about Bitcoin protocol.
Yeah, I want to just underscore all of that. There's so much good material, especially that Chaincode and projects John's worked on. So there is a weekly review club, and that's a great, I'm just going to repeat the same stuff. It's on IRC, it's 1 hour a week, and it's a great way to be looking at PRs and be able to engage and ask your questions, whatever level that is. It can be really intimidating at first to just like get on GitHub and be like, excuse me, what's going on here? And also like is not always appropriate, but those kinds of questions are appropriate, and this is an avenue to ask them. And then there's the OpTech newsletter that comes out weekly, and that is, okay, this is all what's going on in the area. Great. I don't have to go do all the digging. It's just accumulated for me. And then in your free time, there's the Chaincode podcast, which is like the technical podcast of Bitcoin development. These two, Jonas and John, and Carolee host it, and it's really awesome. And then there's the Chaincode like material, which is just this huge aggregation of all sorts of technical material that is a really great diving point to engage in whatever aspects you're most interested in. So whatever avenue is most your cup of tea, there's like so much to further your learning.
Maybe there's a question that I'll throw back your way, which is what was your college major and sort of how did you end up committing to, it says blockchain, but I'll also say Bitcoin.
Yeah, I majored in information systems, which is where business meets computer science. And I managed to like get credits out of all of the CS requirements of this class, of this major. So yeah, I really like kind of just tinkered in college, but I did become a software engineer afterwards. But I would say like most of my learning has been in the professional environment and like hands-on. I fell down the like Bitcoin rabbit hole. I don't know exactly how. I remember being like, oh, trust models and this new idea of a trust model via blockchain, and reading the Bitcoin white paper and just being so fascinated and engaged by it that I just like had to learn more. And this was the first time that I did anything professionally related outside of work. And that's a trend that's just kind of grown over time. And so I started like trying to figure out ways that instead of just consuming, that I could create. And here we are a few years later.
And John, what did you study?
I studied maths, mathematics, many years ago, and spent too many years working in something that wasn't Bitcoin. I guess Bitcoin didn't exist when I graduated. And so I worked in software, in telecoms and network software, in something that, by comparison to Bitcoin, is pretty mundane, but then most things are pretty mundane compared to Bitcoin. So I got bitten by Bitcoin in 2015, quit my job, moved to New York to work on Bitcoin, and here I am.
Amiti, tell me a little bit about maybe you've done a little bit of mentorship in the last year as well. And as you're sort of thinking about ways for people to get involved and maybe some qualities that you've seen of people that you want to invest in, what are some of the things that have popped up, actions that people have taken, just sort of like the grit that people have shown? Can you give us some examples?
Yeah, I think a lot of people feel really excited, but what excites me the most is when the like declaration of excitement is followed up by the commitment of like just taking small steps. And there are some pretty well-defined steps that you can take. Like the first one is to go to GitHub and clone Bitcoin Core and get tests running, have it compile. Because I mean, it's not that difficult of a process, but I learned stuff when I did it. I had never like developed in a compiled environment. And so I think the people that I feel like the most excited about are the ones who follow up with the enthusiasm and then just like take steps and try to engage in the material really thoughtfully and bring forth their skepticism, but also like do the due diligence and try to learn as much as they can. And that really shows up in the actions. And it's really fun. So I think Gloria Zhao is here. And we've just been having so much fun as she's ramping up to, it like reminds me of where I was a year ago, like making PRs that felt small, but actually like took a decent amount of work and iterations, and I learned so much in the process of, and it's really fun for me to be chatting with her and learning from her process as well. And it's really like a two-way thing. So yeah, I'm definitely here as a resource if anyone is interested and has specific questions. Like, I'll try my best to get back to you, but you can always DM me on Twitter, and I don't know, at the very least, try to identify different avenues that you can take to further whatever question you have, even if I can't necessarily answer it myself.
Oh, I hope Gloria was prepared to be webinar famous. John, we've mostly been talking about Bitcoin Core, but you got involved with Bitcoin because of sort of the promise of micropayments and sort of like some other things that we haven't discussed in this webinar. What are other skill sets, other ways that people can get involved in the Bitcoin ecosystem besides just working on Bitcoin Core?
Well, if you're talking about micropayments, then the obvious thing to talk about is Lightning. Lightning is a technology that is built on top of Bitcoin. It's what we call a layer 2 technology. And there are 4 major implementations of Lightning right now. LND from Lightning Labs, C Lightning from Blockstream, Rust Lightning, and Async from Eclair. And so those are all different implementations written in different languages. And there are many other Bitcoin projects across the spectrum. There's things like BTC Pay Server, which is a merchant services, an open source merchant services package for accepting Bitcoin. There are CoinJoin implementations. So there's lots of Bitcoin related projects, open source wallet implementations. In terms of other skill sets, we need all kinds of skill sets to make Bitcoin successful. In the open source world, you need testers, and those testers don't necessarily need to be software developers. You need translators. It would be great if we could get designers involved, but I don't know how that works in open source projects. It doesn't seem to work very well in Bitcoin Core, but it'd be great if there was better UX and more exciting user interfaces. Yeah, so all kinds of things that you can get involved in if you want to help Bitcoin out in general.
And how can people get in touch with you two? What are the best ways to reach out, and if they have follow-up questions, what happens next?
You can DM me on Twitter or email me, amiti@uttarwar.org, and I'll do my best to help you out. Also, by the way, it seems like we have a couple of Q&A questions. John, I'll let you share.
I've been neglecting those.
Well, whilst you look at those, you can reach me on Twitter, the communication medium of choice for Bitcoiners, I guess. Or you can find me every Wednesday at 1700 UTC at PR Review Club on Freenode IRC. So come along and I'll definitely be there.
Amiti, so a question from an anonymous attendee. How do you recommend dealing with PR shyness?
Yeah, so I think that it's important to find things that are useful and look for where along your learning curve you can offer useful contributions. And so one way to do that is to be looking at the code base and have tasks that have already been identified as being useful, but nobody's put in the work yet. And a really great way to start is via the functional test framework that's written in Python. It's much more accessible, and it's a really good way to familiarize yourself with the Bitcoin protocol, because you're pretty much running nodes, starting them up, sending transactions between mempools in the tests. So it's a great learning opportunity, and it is a pretty clear win in terms of if you're able to test a functionality that has intended to be tested or is lacking, that definitely strengthens the code base. So I wouldn't recommend just thinking that you have a grand solution and coding it up and spending a really long time doing this and then just dropping a huge PR of like, here's this feature, it's important. Instead, pay attention to the kinds of conversations that are being had, pay attention to what people are pointing out as useful additions, and try to identify how you can make small changes. And then around reviewing, like Review Club it's a simple answer, it's awesome, and you don't have to be shy because it's the place to be asking those questions.
Cool. I'm going to go a little bit out of order here. John, why do you say it's hard for designer and UX people to get involved in Bitcoin Core?
Not to be discouraging, but just in my experience, it's kind of difficult to get consensus around what good design is, whereas getting consensus around what good code is seems to be easier. So in an open source project, if your contribution is here's some functionality or here's some change to the code, you can eventually get other contributors to say, yeah, that's good, let's merge it. Whereas design decisions just lead to a lot of bike shedding. So everyone wants to paint the bike shed their specific shade of green, and if someone else brings a different paint color to the party, then everyone's going to be unhappy. So I think it's difficult. I don't think it's impossible. I think we can definitely improve the design of the UI in Bitcoin Core. But just in my experience, what I've seen, it seems to be quite difficult to get that consensus.
And Andrew had another comment, just sort of anecdotally, saying that he heard a couple of designers had previously tried to get involved. So in terms of actually getting involved, perhaps partnering with someone who's designing for a Bitcoin Core feature that needs UI, such as creating or signing a partially signed Bitcoin transaction, is that something that you think would work?
Yeah, I think in general, it's basically less established, the role for designers to contribute. And there are these complications that hinder. But I think that kind of looking for projects that are being worked on, because there's a lot of different ways to contribute to the Bitcoin ecosystem that are beyond Bitcoin Core as well. So there are like applications or that run on Bitcoin. So that might be a more accessible way to get more involved as a designer or a related field. And so I think that probably what you were proposing of trying to pair with someone who's developing a functionality makes sense.
Cool. A question from an anonymous attendee. How do you recommend finding a mentor specifically for Bitcoin, and who can help on-ramp and build PR confidence review them? Maybe I'll start with John on that, and but both of you should answer.
Who can help on-ramp and build PR confidence? Well, you can start by reaching out to Amiti and me. Very happy to give pointers to anyone here on how you can get involved in review and potentially at some point opening a PR. I'll say it again, we said it 100 times, but I think review really is the critical thing here for new contributors. If you come to the project and you open a PR and no one's seen you before, and your message is, I'm here to fix everything, here, review my code, that usually doesn't go down as well as coming to the project and reviewing open PRs. We have a surplus of open PRs, about 350 right now. So a really good way to start is to review PRs and talk to Amiti and me, and we'll very happily give you pointers on where to look for those things.
Yeah, so I would say if you go to Bitcoin GitHub project and you're looking at the open PRs, there's a ton of them. So start by looking at the ones that are in the test framework, because that will be more accessible. And then pull somebody's PR and try to understand what they're testing, tinker with it yourself, and then that's something that's accessible to leave a review of like what your findings were, or potentially along the way, you might find little ways that it could be improved or made more clear or something like that. And that can help you familiarize as while you're able to review. And then, as we've mentioned, like review club. So.
Yeah, I don't think you need to have one mentor. If you go and review a PR and you have questions about that PR, you can ask the PR author those questions. You can either leave questions on the PR itself or contact them over IRC. And if you're going there to help them get their PR merged, they're probably going to be happy to answer your questions. And them answering your questions is mentoring you. Like, it's not a mentor role, but they're giving you mentorship by answering that question. So just get involved, help people, and it will become reciprocal. People will help you in return, I think.
I strongly agree. I feel like all the feedback I've gotten in conversations on PRs that like where I'm asking questions, like I feel like almost everyone I've interacted with in Bitcoin has been a mentor to me.
Yeah, I would also add that the maintainers put a lot of work into categorizing PRs, and the labels are very good. Fanquake is possibly not human in terms of how quickly he puts labels on things, and there's a lot of work that goes into that. There's also 2 labels that you might want to look out for regarding PRs or just issues in general, and that's good first issue and up for grabs. So good first issues are obviously issues if you're just getting involved and you feel like you like to author something. I would suggest starting with the review, but if you're ready to start writing code, a good first issue would be a good place to look for things. And then up for grabs are abandoned PRs, and it's a little bit hard to judge how difficult or the reasons why some of those PRs have been abandoned. But a strategy that I used for getting a few PRs in last year was just looking at things that someone had just walked away from the project and they'd done a lot of the work, but they needed to sort of a little bit of grit to get it over the finish line. So it's another way to contribute to the project, and it worked for me. Okay, next question from Regina. I'm graduating in May and I don't have an internship experience in Bitcoin/blockchain. What advice and resources do you suggest for getting a new grad role in the field? Also, do you know of any Bitcoin/blockchain companies that are currently hiring? John.
I feel like this is in your wheelhouse, Jonas.
Okay. Yeah, I would say, we meet lots of folks through mostly our residency application process. It is difficult to take a chance on someone without experience. And when I say experience, I don't mean necessarily work experience. I just mean that you've never taken a step to actually get involved. And with a lot of these open source projects, the barrier to entry is mostly psychological. And I think the importance of Amiti talking about her last year, and John, has been at this for 3 years, but can easily put himself in his shoes before he started. John was, it hasn't been mentioned today, but John was in the first Chaincode residency, and there's only 3 attendees. So both of the people who have presented today have not been at this that long, which should give you confidence that if you really apply yourself, that you can level up pretty quickly. When you're a new graduate, and I think this goes, I've done a lot of hiring, outside of Bitcoin and outside of sort of this space. When you're taking a chance on someone who has mostly been doing coursework. It's a little bit hard to actually understand sort of whether they want to dedicate themselves to, whether it's being a software engineer, whether it's working on Bitcoin, whatever the case may be. It's a lot easier if you're looking, if I'm looking at a GitHub profile and I see that someone has tried something, or I see some sort of track record. And you can create that track record through blog posts. You can create that track record through attending seminars and sort of like getting to know people. You can create that track record in a lot of different ways, but somehow you have to create artifacts so that I have confidence that you're interested and you're going to not just come for a 3-month internship and then I'll never hear from you again, but this is a first step to a long path. So I'm happy to, Regina or anybody else, I am personally happy to talk about what that first step looks like and sort of map out, you know, what the longer path might look like. But you have to take the first step of reaching out, of trying some things. It's a little hard for us to just sort of like throw darts and hope that you know, because you interview well or whatever the case may be, that you're going to be doing this for a long time. Anyone else have anything to add?
Oh, sorry. If I could jump in for a second, I think it could be a really good segue into two really short questions I had in mind as well. Amiti, John, I think everybody who gives talks or is a part of this ecosystem talks about the Bitcoin or blockchain rabbit hole and how you get kind of sucked in and it sticks. Do you guys want to maybe talk about like what that looked like for you and why, what aspect of this community made that rabbit hole for you? Amiti, if you want to start.
I mean, to me, I think that global money is inevitable. And I think Bitcoin is the only experiment that we have in a viable global money. And that's really, in terms of impact, what's caught my attention. And then I think the ride is also really fun. Just the kinds of engineering challenges that I get to engage with in a day-to-day basis is feels like an intellectual play space. And so I think that there are a lot of nuances of the particular path that I took and a lot of variety of incentives of reasons along the way. Like meeting really cool people and getting to collaborate and learn from them, it has definitely contributed to my interest in Bitcoin. But I think at the end of the day, it's a really meaningful project and it's also really fun.
John, how about you?
Yeah, it is. Elena on the chat is agreeing with Amiti that it's an intellectual play space. I agree too. I got interested in Bitcoin in 2015 and yeah, fell down that rabbit hole just like other people, and figured out pretty quickly that it was not if I was going to quit my job and dedicate myself to Bitcoin full time, but when. And I knew it had to be within a year. And so within a year, I quit my job and came to the Chaincode residency in 2016. And I'll echo what Jonas said about establishing a track record. Before the residency, I hadn't contributed to Bitcoin Core, but I wrote a series of blog posts on the Lightning Network. And that was something that I put in my application for the residency. And I think it probably helped my chances because it demonstrated that I'd spent many hours digging into the technical underpinnings of the Lightning Network and that I had a genuine interest in this thing. Amiti applied to the 2018 residency and didn't quite have enough experience to get onto that one, and then applied to the 2019 residency And in the meantime, she'd skilled up and she'd started contributing to Bitcoin Core and had demonstrated that track record of having a continued interest in Bitcoin and having the grit and determination to actually get changes merged into Bitcoin Core. So that really helped her application. So yeah, I totally agree with what Jonas is saying about establishing that track record.
The next question I actually had in mind was, Jonas, you talked about the psychological barrier and how we have to take the first step. I was curious about what the greatest challenge was for you guys throughout your journey, but being mindful of the time that we only have 6 more minutes left and the 2 more interesting questions, if anybody want to just take grabs for, you know, those 3 questions, and we could wrap it off. So, you know, anybody, if you guys want to just choose a question to answer, go for it. No?
Amiti, maybe you want to talk about your greatest challenge. You can take it from there.
I mean, that changes every day. Like, I could tell you what I'm working on now. That I don't think that's the intent of the question. I'm not sure.
Punt. Great. Anonymous attendee, how welcoming is the Bitcoin community to new ideas? For example, how can I pitch my findings in a research paper to the community? John?
That is a abstract question that is difficult to answer in the abstract. Depending on the idea, people are more or less excited about it. And in general, I would say that ideas are pretty common. But a lot of people come into this space and have ideas. And a lot of the work of keeping up to date with Bitcoin is being able to pass through a lot of the noise there. So I think having a track record helps. There are exceptions, like Satoshi didn't have a track record when the white paper was released, or the Wimble paper was dropped by someone anonymous. But in general, I think people need some kind of heuristic to parse through what they should be paying attention to, and that heuristic is reputation that's built up over time. So if you have shown yourself to be a serious contributor and that you understand the concepts of Bitcoin well, and you've made contributions in the past, and they'll probably pay more attention to your paper and your ideas, because that's how we have to prioritize our time, I think.
The other way the other opportunity I think comes through conferences, and there's various conferences, some more academic focused and some less academic, and so you have time on a stage to present your proposal. There is a screening process that goes into those conferences, so sort of, you know, to whoever you're appealing to on the selection committee. But conferences might be a way to get in front of a Bitcoin audience to pitch your idea also. Last question from Gloria Wang. There are some people working on the Rust implementation now. Do you see more and more people moving over there from C++?
Yeah, there's a lot of excitement around Rust. People love Rust, and for good reason. It's a lovely language and has lots of great safety features. So yeah, there's Rust Lightning. There isn't, in fact, a full node implementation of Bitcoin in Rust, but there's a library of Bitcoin functions called Rust Bitcoin, and I expect we'll see lots more Rust projects in the Bitcoin and cryptocurrency space over the coming years, because it's a very popular language and just becoming more popular over time.
All right, I think we went through a bunch of questions. They're all really great. Thank you so much. It's now 58 of 10 a.m. Before we end off, I'd like to send you guys this link on the chat. It's like a little feedback form. If you guys could fill it out before we end off, it would be great. So if you guys could go on it right now, it just takes like 30 seconds. That would be wonderful. But all in all, thank you guys so much for being here today. It was so much fun. Thank you, John, Amiti, Jonas. You guys were amazing. And yeah, do you guys have any ending remarks?
Thanks, Elaine. Thanks for organizing.
Of course. Thank you. It was so much fun. Okay, I think that's it. Thank you guys. Bye.